let's take a look at problem 5.15, which involves interpreting beta. A firm wishes to assess the impact of changes in the market return on an asset that has a beta of 1.2. Now I'm reading in the yellow, which is the requirement. And we're asked to solve items A through D. So on item A, we're asked if the market return increased by 15%, what impact would this change be expected to have on the asset's return? On B, we're asked what happens if it decreases by 8%. C says what happens if it remains unchanged. And D says, would this asset be considered more or less risky than the market? Okay, now in the green section, I have a common definition of beta. Now the beta coefficient, represented by B, is a relative measure of non-diversifiable risk. So it measures the degree of movement we would expect on an asset or an investment's return in a response to a change in what we see in the overall market. Now it's used in the capital asset pricing model, which I've also listed in green, and the beta portion I've shown in red to show where it fills in. Now the capital asset pricing model says the required return, and I have a typo here, let me fix that. The required return or expected return on an asset J would be equal to the risk-free rate of return, commonly measured by the U.S. Treasury bill, plus the beta coefficient times the overall market return minus the risk-free rate. And that's how you would apply the capital asset pricing model. Now, we're just asked to solve beta. Okay, let's solve A first. We know that on part A, the current beta is 1.2. So why don't we drop that down? Then we know that they're asking what happens if we get a 15% increase. Let me insert a row here and take off the green. Okay, so this would be beta. This would be the change, and we think we're going to get a 15%. So what would be the expected increase? Okay, and I think if we just multiply the beta times the 15%, we come up with an 18% increase. And I'll put a decimal point in to get us a little bit more accurate result. Okay, and that takes care of A. Now on B, it just wants to highlight that, huh? On B, we also start with a beta of 1.2, and we're told what if the market rate decreases by 8%? So let's put in a negative 8% there, and then calculate it again. And what that tells us is we would expect a decrease of 9.6% on that particular asset. Now in C, if there's no change, this should be fairly obvious. If we've got a 0% to multiply by, then there would be no change, right, on the return we would expect from this asset. Now in part D, we're asked, would this asset be considered more or less risky than the market? The overall risk of the market has a value of 1. So 1.2 is greater than 1. So that means it is more risky. And that's how you would interpret that. The higher the beta makes the return more risky than the market. If it was less than 1, then that particular stock or investment or asset would be less risky than the market overall.